Hello, dear students. I hope my dear students are well and fine um, and staying indoors because we know in these critical times we have to be very alert and vigilant and we have to take care of ourselves and by maintaining social distance and staying indoors. Having said that, we cannot uh, avoid from our basic duties. So we as teachers of every university all over the world, of every school, colleges, are trying their best to use the multimedia tools to teach you and continue this teaching and learning process. And I'm very much sure that every student is also trying their best to take advantage of this lost time by reflecting or engaging in our lectures, our materials, which we have given to you by Google Classroom, WhatsApp, mail, etc. Okay, so I will give the link to this video. It will be uploaded in YouTube, and I will make this a bit quick because otherwise the upload size, the file size will be too much, and the upload time will be too much. So let us start. We will talk about fluid mechanics, the third module. Okay, the third module is kinematics of fluid or kinematics of flow. So what is kinematics? Kinematics is defined as the branch of science which deals with the motion of the particles. Okay, motion of the particle, very important, particles of the fluid without considering the forces caused by the motion. That means we will deal with kinematics deal with the motion of the particle. We suppose how the particles of fluid, what behavior, with what behavior, what characteristics they flow. Okay, because of the motion, but we don't consider the forces that are causing those motion. Okay, because for motion there has to be some force, but we're not bothered with the forces in this kinematics part. Okay, this is the model 3, of course. The velocity at any point in a flow field at any time is studied in this branch of fluid mechanics. Once the velocity is known, then the pressure distribution and hence the forces acting on the fluids can be determined. So in kinematics, we talk about velocity, and we observe the velocity of the fluid particle, how or what behavior they have, and in turn, if we want to find out, we can find out the forces from, and we can derive the forces from the velocity itself. The next is the analysis method. In kinematics, the analysis is done by two approaches. Okay, so these approaches are, one is Lagrangian approach, another is Eulerian approach. So what happens in Lagrangian approach? What we do, we take the movement of only one particle. Suppose this is a river. Okay, so there are thousands of particles, but we take only one. We are considering only on this particular with this specific particle, and we will see how this particle moves from here to here, suppose from here to here. So we'll observe and analyze this particle only. So if we say that this is moving in this direction, so we can find out that this is having a path line of this. Okay, so this is how Lagrangian approach is done. Next is Eulerian approach. In this approach, what we do, we observe the on a point of fluid. Suppose this is again a river, okay, a stream of flow, a river, a flow, a drain, whatever, water is flowing in this direction. So we don't consider one particle, we consider one section of this uh, flow, and we will suppose there are millions of particles or thousands of particles inside. Okay, there are different particles. Okay, these are particles of the fluid, but we will only observe whatever is happening inside this section. Okay, whatever is happening inside this section. So this is Eulerian. In Eulerian we talk about the space, and in Lagrangian we talk about the different motion that one singular particle takes. So next one is the different types of fluid flow. We know the different types of fluid, but this is the different types of flow, how the fluid flows. Okay, so there are different types. Okay, and we'll talk about this in a very quick manner. Steady and unsteady flows. So in a steady and unsteady flow, what happens? Let us go to the picture directly, then we can understand this one. So these are the lines of flow. Okay, these arrows are the lines of flow. If you observe, these arrows are exactly the similar as this one. The arrows in this picture and this picture are exactly the same, but what is different in this picture is the time. Suppose the time in this picture is t0 and the time in this picture is t5. Okay, let's say 5 minutes. That means this is 0 minute, this is 5 minutes. So this is the future. Suppose this we consider as a present. This is the present. Sorry for this. Okay, and this is the future. So in future of 5 minutes, the future of 5 minutes, the velocity, sorry, the characteristics of the fluid does not change. It is the same. See, the arrows are same. And what are the characteristics of fluid? It is the velocity, pressure, density, discharge. Okay, so these are the different parameters. So with respect to time, the velocity, the pressure, the density does not change. Hence, it is equal to 0. Del V by del T mathematically is equal to 0. But for unsteady flow, if we observe the arrows are different. That means something is different. What is different? The flow characteristics. The velocity might be different, the discharge might be different, the speed of the flow, okay, so density of the flow. So something is different at this present situation and after 5 minutes. Okay, so when the time changes, the characteristics of flow also changes. Hence it is known as unsteady flow. And mathematically, del v by del t, del p by del t, del rho by del t is not equal to 0. That means it is not constant. For uniform flow, we don't talk about time. We take time as constant. Okay, time is constant. So this whole flow is for one time. Suppose this is at now what is the time at my watch? It is 8. So at 8 p.m. we are observing this particular flow, but we are defining it with respect to distance. Okay, suppose this is okay, suppose this is 0 meter and this is 5 meter. So in 5 meter, from 0 to 5 meter, the flow is exactly the same. In this particular volume, this particular stretch, the flow is having a same and constant characteristics of velocity, pressure, density, etc. But from 5 to 10 meters, suppose, the characteristics are very much changing. Hence, suppose we are talking about velocity. Let us take one example, velocity. Okay, with respect to distance from 5 to 10, that means it is varying 5, 6, 7, 8, 9, 10, right? So with respect to distance, the time is changing. Sorry, with respect to distance, the velocity is changing. See, the velocity will be a bit more here. It is going down, and it will be when it is hitting the ground, it will be a bit less here. So different types of changes are there. The discharge is also changed, energy is different, so everything is changing. So the characteristics of flow is changing with respect to distance only, not with time, because time is constant, remember here. Okay, so next one is laminar and turbulent flow. So if you see, if we open our tap, okay, in our basin to wash our hand, if you just let it open a very little bit, then you'll see that the flow is very smooth. So that particular flow is known as laminar flow, where the fluid particles move along a very smooth line over each other. This is known as one lamina. Okay, this is another lamina. So this lamina is over this lamina is over this. So they are very much gliding over each other very smoothly. And this flow of line is known as streamline. Okay, streamline. Also, laminar flow is known as viscous flow. This is important. Laminar flow is known as viscous flow. So, what is turbulent flow? If you take the example of the tap again, if you open the tap fully, completely, then the flow of water will be a bit harsh, a bit rough, and the path of this particle will be random and ragged or zigzag. Okay, so this is how it takes. Okay, so for a pipe flow now, what is the way we can how we can say that whether the flow is laminar or whether the flow is turbulent? To determine that, we have a particular equation or number. Sorry, the number is known as Reynolds number, given by the famous scientist Mr. Reynolds. uh, so ReVd by nu. So this is the formula. V is the velocity, d is the diameter of the pipe. Okay, we are talking about a pipe now. So this is suppose a pipe. So this is the d, this is d. Okay, and the v, this is the velocity of flow, that is the flow of water or any fluid that is passing. This is the velocity, this is the diameter, and this nu is the viscosity of the particular fluid which is flowing to the pipe. Okay, so hence these equations are uh, for this Reynolds number. This is nothing but whenever we change the kinematic viscosity into dynamic viscosity, so we are introducing the term mu and density. Okay, but for your assignment, okay, this is just not an assignment, just a task I'm giving you. We have said that it is possible to find out whether the flow is laminar or turbulent with the help of Reynolds number. But what should be the number for which we can say that the flow is laminar or the flow is turbulent? There should be some range, some number. Suppose I say that if Reynolds number is 0, it is laminar. If Reynolds number is 1, it is turbulent. But that is not 0 and 1. It is something different. So you find it yourself and report it to me. Okay, so the next one is compressible and incompressible. Very shortly I'll say it, very easy. So if you see this diagram, this is the flow of, suppose this is the flow flowing through a pipe. This pipe is having this diameter, so this diameter is also same, and the flow is not compressed. Okay, the flow is not compressed, so this is incompressible flow. Okay, we cannot compress the flow. Here the flow is compressed. So when the flow is compressed, the density changes. Hence, for a compressible flow, density is not constant. And when something is not constant, we understand that it is changing. But for incompressible, it is constant. That means the density is not changing, right? Rotational and irrotational, very important one. So take this example for rotational. Let us consider it to be the sun. Okay, these are actually water. Okay, this is fluid, not water, sorry, fluid. These are fluid particles. So let us consider this fluid particle to be earth, and then we can understand that means this particle is also moving in a particular streamline, and also it is rotating in its own axis, that is known as rotational flow. But when a flow does not rotate, it is revolving around this particular sun, suppose, or passing through the streamline that it is assigned to, but it is not rotating. If you observe carefully, hence I have not given the PDF, I have given the PPT presentation format so that you can observe the animation properly. Okay, so this type of flow is known as irrotational. One dimensional flow, very simple to understand. We know there are three dimensions of space, x, y, z. Okay, there are only three dimensions of space till now. So there are no more dimensions. So if we say that the flow is only in one direction, suppose in this case we are talking about x. Okay, so whatever flow is there in x, it is known as, the velocity is known as u. Whatever velocity is there in y, it is known as v, and z is known as w. But for one dimension case, this v is equal to 0 and w is equal to 0. That means there is no flow. Okay, in these two direction, flow is only in this direction. This is not equal to 0, not equal to 0. Okay, so this is what one dimensional flow. You can see the diagram, it is going only in this particular direction. Two dimensional, same, this flow is going to this direction, right? This flow is from one here to here, so it is following x direction, but it is also going down, right? It is going down. So when it is going down, that means it is going in this y direction. So hence u and v both are the functions of x and y. three-dimensional flow. This is actually the real type of flow which we see, uh, which is going in X and Y. This is Y. Okay, we have some depth, and also in this direction. So there are three types of flow, and this is not one-dimensional flow. This is 3D. Okay, I've kept this that the typo intentionally so that you understand, don't make the mistake. This is not one-dimensional flow, this is three-dimensional flow. So I think we are finished with this. So I hope everyone is having some idea. Okay, everyone is having some idea what kinematics of fluid is, and this is just a basic introductory part. I'll be sending another video, other materials I'll be providing along with this one. So I hope all of you understand it. If you have any doubt, you can always contact me, WhatsApp me, mail me. Okay, but don't mail me at 12:30 at night or 11 at night. At your convenient time, in proper time, you mail or contact me. Okay, so take care guys and be safe.